Hello, you are welcome to the class today. My name is Dr. Kingsley. Okay, in my class today, I'll be taking us on mole concepts. Remember, we have started mole concepts where I give you formulas on different ways we can calculate the number of moles. Also, before I go on today, because what I want to do today is to give you some calculations on what I have taught previously. But I'm going to recap on the formulas to calculate the number of moles, okay? So that it will be easier for us to follow up. Now, we agree that number of moles, N, can be calculated using given mass, M, divided by molar mass. So number of moles is mass over molar mass. That is the first equation I gave you. Then number 2, number of moles can also be calculated using given volume over molar volume. The small v is a given volume, while the capital V is molar volume. And remember that molar volume of gases at STP is 22.4 dm³. Number 3, we also agree that number of moles, okay, is equals to concentration in mole per dm³ divided by volume, okay, in dm³. Number of moles is equals to concentration in mole per dm³, okay, multiplied by volume in dm³. We also agree that number of moles is equals to what? Pressure multiplied by volume all over molar gas constant multiplied by temperature, absolute temperature. Number of moles is what? Pressure multiplied by volume, okay, then divided by molar gas constant multiplied by what? Temperature, absolute temperature. Then number 5, number of moles is also equals to number of particles, that is N, number of particles over Avogadro's number of particles. Number of moles is equals to what? Number of particles divided by Avogadro's number of particles. Now we want to take what? Questions. Now question 1 says calculate, okay, the number of moles. Calculate the number of moles in 40 grams of Na2 SO4. So we have to calculate the number of moles present in 40 grams of, this is what? Sodium tetraoxosulfate 6. Now, if you look at this is the given mass. We can get the molar mass from here. So we can use number of moles is equals to given mass over molar mass. Okay, where the given mass now, M, is equals to 40 grams. That is the mass they give us, okay, in the equation. That is why I call it the given mass. So the given mass is 40 grams. Then the molar mass, we can get molar mass of Na2, okay, SO4. So how do we get the molar mass? Remember, the mass, atomic mass of sodium is 23. So 23 for sodium multiply by 2, because we have 2 atoms of sodium here. So multiply by 2, okay, then plus sulfur. What is the, okay, atomic mass of sulfur is 32. Then plus oxygen. We have 4 atoms of, 4 oxygens here. 4 oxygen, moles of atom of oxygen. 4 moles of atom of oxygen. So if we are to get the oxygen here, we remember the atomic mass of oxygen is 16. So but we'll be multiplying by 4. Multiply by 4. So that is, okay, that. Then when we, of course, sum all these things together, when we sum them, we can now see that the molar mass, when we sum this, is 142 gram per mole. That becomes the what? The molar mass. Then, okay, we have gotten, we know the mass, the given mass, and now we know the what? The molar mass. Then the number of moles will be what? the given mass over the molar mass. What is the given mass? The given mass is 40, okay, 40 grams, okay, divided by the molar mass is 142, sorry, 142 grams per mole, okay. When we divide this, we'll be getting, okay, 0.282 moles. So that is the answer for the number of moles. So now we go to question 2. We go to question 2. Question 2 on number of moles is saying we should calculate the number of moles in 30 centimeter cube of oxygen gas at STP. Now, if you look at this question, they give us volume. That volume is what we call the given volume. So remember, number of moles is given volume, which is what? Small v. Then divided by, okay, molar volume. Okay. Now, the given volume is 30 centimeter cube. Alright. Then the molar volume, V, molar volume of gases at STP is 22.4 dm cube. That is molar volume of gases at STP, 22.4 dm cube. Now remember that this is in dm cube, while the given volume is in centimeter cube. Either I convert this one to centimeter cube, so that it will be centimeter cube, or you convert this one to dm cube, so that it become dm cube and dm cube. Now let us use dm cube. That means we have to convert 30 centimeter cube to dm cube. How do we convert centimeter cube to dm cube? We divide by 1000. So it will be what? It will be 30 over 1000. So that will give us 0.03, okay, dm cube. So this is in dm cube and this is in dm cube. Then the number of mole is given volume over molar volume. Now the given volume is 0.03, okay, dm cube, okay. Then the molar volume of gases is 22.4 dm cube, okay, dm cube, okay. Now per mole. Now when we divide this, we will be obtaining number of mole to become 0.00134 moles to be our. So we'll go to question 3 now. Question 3. Now question 3 is saying that we should calculate the number of moles of H2SO4 present in 500 centimeter cube of 0.046 mole per dm cube H2SO4 solution. Now we are given what? Concentration in mole per dm cube, and we are given volume. Now if we want to get the number of mole, remember number of moles is equals to what? Concentration multiplied by what? By volume. Now look at number 3. Number of moles is equals to concentration multiplied by volume. Okay, so the concentration must be should be in mole per dm cube. That is 0.046 mole per dm cube, right? Then the volume is 500 centimeter cube, but we don't use what? Centimeter cube. We'll convert to dm cube because the volume here should be in what? In dm cube. That is to say, we'll convert from centimeter cube to dm cube by dividing by 1000. So that will give us what? 0.5, okay, dm cube. So that our number of mole, which is concentration multiplied by volume in dm cube, becomes concentration, which is 0.046, okay, multiplied by volume, which is 0.5. So when we multiply out, okay, we'll be getting 0.023. So we come to question 4 now. Question 4 says calculate the number of moles if 300 centimeter cube of an ideal gas exerts a pressure of 650 millimeter mercury at 27 degrees Celsius. Now let us bring out our parameters. We see that the volume given to us is 300 centimeter cube. Okay, and the pressure is 650, okay, mmHg, and temperature is 27 degrees Celsius. Now we convert the temperature, okay, from degrees Celsius to Kelvin. How do you convert degrees Celsius to Kelvin? You add 273. So it will become 227 plus 273 for it to be in Kelvin. So that will give us 300, okay, Kelvin. Remember, if you look at this, look at the formulas for number of moles. You exactly know that this is the formula we are using. Since this is an ideal gas, we know that molar gas constant is 0.0821, okay, atm dm cube per mole, okay, per Kelvin. That is the constant, molar gas constant, 0.0821 atm dm cube per mole per Kelvin. That means if you are using this equation to calculate number of mole, because of the R, the molar gas constant, the unit of pressure should be in what? atm, while the unit of volume should be in dm cube. That means the volume here should be in dm cube. So we convert it to dm cube, which is 300 over, okay, 1000. You want to convert from centimeter cube to dm cube, you divide by 1000. That will give us what? 0.3 dm cube, right? Then we'll convert what? The pressure here to what? To atm. Remember, the molar gas constant is in atm. So convert this to atm. When we do that, how do you convert a millimeter mercury to atm? If you want to convert millimeter mercury to atm, you know that 1 atm is equals to 760, okay, millimeter mercury. That means if you want to convert millimeter mercury to atm, we'll divide by 760. So that will become 650 divided by what? 760. That will give us 0.855, okay, 3 in atm. So it's now in atm. So if we are solving now, we use number of mole to be equals to what? PV over RT. That will give us pressure is what? 0.855. That is 0.8553 multiplied by the volume. Our volume is 0.3. Then everything divided by molar gas constant, 0.0821 multiplied by temperature, absolute temperature, which is 300. So if you multiply out, the number of mole will be 0.01 mole. So that is the answer. So we are taking the fifth question now. Okay, if you have followed me up till now, this class up till now, please do well to hit the subscribe button so that you can be getting all the lessons, okay, and the questions that I will be giving out. Now, it says calculate the number of moles of copper present in 3.2 times 10 raised to 20 atoms of copper. Now, this number you see here is atom. An atom is a particle. So this is number of what? Particles. You are given number of particles and they are asked to calculate the number of moles. Now if you look at this, you see that number of moles is equals to number of particles divided by Avogadro's number of particles. That is to say, number of mole is number of particles over Avogadro's number of particles. Now the number of particles given to us is 3.2 times 10 raised power 20 atoms, okay? But remember, Avogadro's number of particles is a constant, okay? A constant given by the Italian scientist Amedeo Avogadro, okay? And the value for that constant, okay, is 6.022 times 10 raised power 23 atoms. That is the value for that constant. Therefore, it means that number of moles will become number of particles all over Avogadro's number of particles, which is number of particles is 3.2 times 10 raised to power 20 atoms divided by Avogadro's number of particles 6.022 times 10 raised to power 23. Okay, when you divide this, okay, we'll be having 5.31 times 10 raised to power minus 4 mole. That is the number of mole. Please, okay, I want you to subscribe to my channel, okay, follow me up and share my videos to help you, okay, to get more of these classes. Thank you very much. My name is Dr. Kingsley.